Hello students, now we are going to start fourth unit of crash course Gravity and Gravitation. It is fourth unit of your crash course. And unit is Gravitation. Generally, we associate gravitation with Newton. He saw one apple falling down and got the idea of gravitation. But actual calculation before Newton was made by Kepler. Kepler studied the planetary motion and he gave three rules which are known as Kepler's laws. First, he gave idea of the orbit in which planets are revolving around the sun. He told us that planets are not revolving in circular orbits. Shape of orbits is elliptical and sun is not at the center of ellipse. It is situated at one of its foci. Means you know ellipse. This. It is minor axis and it is major axis. It is center. Two focal points are there at same distance from center. One is on left hand side and one is on right hand side. You see, the sun is situated at one of its focus. This law is known as law of orbit. Law of orbit. That shape of orbit is elliptical and sun is situated at one of its focus. Second, it was law of area. Law of area. Actually, it was the law of conservation of angular momentum. He told us that line joining the sun and the planet, suppose it is the orbit of Earth, one planet, that line joining the sun with planet covers equal area in equal time interval. Suppose in 3 months, planet reach from this position to this position. So area swept by the planet is this. So in every 3 months, this line will swept same area. But when planet is at this position, now length of line is very large than this. But in 3 months, if it has to swept same area, it means now the planet will slow down so that that bigger line will swept equal area in equal time interval. If here it took 3 months, in this portion it will also take 3 months. From this point to this point. It is known as law of area. It is known as law of area. In your NEET exam, sometimes they are framing objective on this only. They will give you different position of satellite. See, in your picture there are 4 different position of satellites. P, P dash, P double dash and P triple dash. At which position, they will ask you, the kinetic energy is maximum. We know that as planet is moving away from the sun, the length of line joining planet and sun is increasing, but this line has to travel same area in same interval of time. So speed of planet is going decreasing. It means kinetic energy is decreasing. So kinetic energy should be less than at the point which is at farthest distance from S. Means in this figure, at P double triple dash, kinetic energy should be minimum. Getting my point? So it was law of area. The most important law, third law, it was the law of time period. Law of time period. From which Newton got its law of gravitation. Newton's law of universal gravitation was the result of this law. This law was that for each and every planet, time period means time to complete one complete cycle in its orbit is directly proportional to mean radius, is directly proportional to cube of mean radius. It was law of time period. So these were three laws given by Kepler. After studying these laws, Newton gave its most famous Newton's law of universal gravitation. In universe, each object is attracting another object, and force of attraction or force of repulsion between two objects depends upon masses of the object, product of masses of object, and it is inversely proportional to square of distance between them. And we are removing this proportionality sign, we are getting one constant which is known as universal gravitational constant. It means for whole universe, its value is constant. Two physicists, Boyce and Cavendish, they calculated the value of G in lab and they got the value of G 6.67 into 10 to the power minus 11 Newton meter square per kg square. But if in these two objects, one object is Earth and another object is an object on Earth's surface, ME means mass of Earth, then this force is known as gravity. It is known as gravity, and then distance between two objects, it should be equal to radius of Earth, because we are assuming that whole mass of Earth is at its center. So distance between object which is situated on the surface of Earth and center of Earth, it should be equal to radius of Earth. But we know that according to Newton's second law, force is equals to mass into acceleration. Cancel this mass with this mass. What you will get? You will get G is equals to GME by RE square. Getting my point? So in this way, we can calculate the value of acceleration due to gravity. the value of acceleration due to gravity. Now there are variation in the value of g due to so many factors. If you are going at a height, distance between object and Earth's center is changing, so value of g will change. We have calculated in theory slides that when you are going at a height, after using binomial theorem, we have calculated that g dash should be g into 1 minus 2h by re, nearly. Means it was a prox calculation. And when we are going at a depth, we are getting g dash is equals to g into 1 minus h upon re. On height, we are getting this. With depth, we are getting this. Why it is decreasing? When we are going inside the earth, distance is decreasing. So f should increase, g should increase, r is decreasing. No. We know that in a gravitational shell, gravitational field is 0. So when we are going inside the earth, we are not now on whole earth. We are only on a small part of earth. At h depth, you are not standing surface of earth. So we have to consider mass of this portion only. Since value of mass is reduced, so value of g will decrease, and it will decrease in this manner. Due to rotation of earth, again value of g is changing. What is happening? Earth is rotating about its own axis, means like this. So every object on Earth's surface is moving in a circle with same angular velocity that is of Earth, means with time period 24 hours. To rotate in a circle, particle need centripetal force. From where it will get? It will take this centripetal force from the attractive force between object and earth. So since it is using one part of gravity in rotating or maintaining itself in this circle, so it is using one part of gravity means mg. So mg is reducing, mass is not reducing, means g is reducing. So due to rotation of earth, the value of g is changing according to the formula. G dash is equals to g minus r square, r omega square cos square lambda, g minus r omega square cos square lambda. Lambda is the latitude. See, this angle is known as lambda. If lambda is equals to 0, it means you are on equator. Lambda 0 means you are on equator. And it is the maximum value of cos 0, 1. So this portion is maximum, means g dash will be minimum. So according to this formula, g dash should be minimum at equator due to rotation of earth. But if we are moving to poles, lambda will become 90 degree. Lambda is equals to 90 degree at poles. So g dash is equals to g, because cos 90 is 0. It means the rotation of earth is not putting any effect on the objects which are situated at poles, because if object is at pole, it will move in 0 radius circle, so it doesn't need any centripetal force. Again, second reason is there why at poles value of G is maximum. Earth is not perfectly spherical. So polar radius is less than the equatorial radius and radius is in denominator. If polar radius is less, G should be maximum at that place. So these were the reasons why value of G is different at different places. But in solving numerical, generally we are taking G 9.8 or 10. Where is the value 9.8? We took this value at sea level and at 45-degree latitude. On sea level, at 45-degree latitude, we are taking this value, mean value of G. So we are using a numerical that value, which is nearly 9.81. But if it is not given in numerical, you can take 10 meters per second square. So it was all about the value of G and its variation. Now, like electric field, masses are putting gravitational field. If gravitational field is there, why gravitational field we are talking about? If I am putting one mass at this point, due to gravitational attraction, it will attract another mass towards itself. But this force depends upon the distance between these two. If distance is increasing, this force is sharply decreasing because it is inversely proportional to the square of the distance. So if R is continuously increasing, at some place F will become 0. If R is increasing, F is decreasing. At some place it will become 0. So technically we will say that second object is now out of the gravitational field of first object. So it was the concept of gravitational field. So in gravitational field, you can calculate intensity of gravitational field just like intensity of magnetic field or intensity of electric field. You can calculate gravitational potential like electrical potential or magnetic potential. Definition is almost same, only in place of unit pole or unit charge, you have to say unit mass. It means if you are talking about gravitational intensity, so gravitational intensity at a distance r from mass m is force experienced by unit mass kept at that point. What force it will experience? We know that G m1, m2 is 1 upon r square. So if this mass is earth and object is at the surface of earth, we will take this r. What we will go then? We will say F is equals to G m by r square, and intensity we can represent by I. Intensity due to gravitational field Ig. You can see it is the value of acceleration due to gravity, same value what we are getting here. So what is acceleration due to gravity? It is equal to intensity of gravitational field due to earth at that point. Like electric field, you can calculate gravitational field. Gravitational field means work done in bringing a unit mass from infinity to that point. So like that, when you will calculate, you will get gravitational potential minus G. If we are talking about earth, and at earth's surface it is this. Otherwise, for any mass it is Gm upon r. So with the help of gravitational potential, we can define gravitational potential energy. What is gravitational potential energy? Work done in bringing any mass from infinity to that point. We know the definition of gravitational potential. Gravitational potential is work done in bringing a unit mass from infinity to that point. It is known as gravitational potential. But if you are taking whole object, then it will become gravitational potential energy. So work done in bringing a mass m from infinity to a point in gravitational field is known as gravitational potential energy. It is gravitational potential energy. So it will be m times of this. If you are talking about Earth, it should be this, or in general, it should be this. You can see that gravitational potential energy at Earth's surface is negative. That's why any object on Earth's surface cannot leave the surface, because its energy is negative. But anyhow, if you are able to supply this amount of energy to any object, then it will escape from the Earth. Suppose you have a stone in your hand and mass of this stone is m, and you want that it should escape from Earth's surface, and you are, for this purpose, you are throwing it with velocity v. It means you are supplying this object an amount of energy which should be equal to half mv square. If this energy can make this zero, means this positive energy in amount if is equal to this energy, then only it will escape the Earth. Means you are throwing the stone, its velocity should be of this range 2 gme upon re. Since now your stone is able to escape the Earth, so we will say this velocity is escape velocity from surface of Earth. Since small m is cancelled out, it means escape velocity is independent of the mass. You throw a 1 kg mass or 100 kg mass, velocity for escaping from Earth's surface should be same. So what is the value of VE? We can calculate this. We know that at Earth's surface G is equals to gme upon re square. So we can replace gme by gre square. So what we are getting? 2gre square. Re means radius of Earth. So escape velocity is root 2 gre. Getting my point? You know the value of g, you know the radius of Earth. 6,370 kilometer, nearly 6,400 kilometer. If you calculate it, you will get 11.2 kilometer per second. It means if you are capable to throw one object with this speed, it will not come back on Earth. It will cross the gravitational field of Earth and it will now launch at the space, in space. So it is escape velocity from Earth's surface. So that is the concept. Since the gases have their root mean square speed less than this, therefore on Earth's surface there is atmosphere. But on Moon, escape velocities, that value is less, and gases have their RMS value greater than that. That's why there is no atmosphere on moon.